Hello and welcome to our webinar, Undet Point Cloud Software. And this time we're going to have a talk with Simon from Precision Air Surveys. I'm Povilas, by the way, Undet Point Cloud Software Business Development Manager, former architectural designer and product manager within AEC industry. And Simon is here representing the Precision Air Surveys. He's the founder and director of the company. And Simon, if I'm correct, you have over 30 years of experience in the survey industry.
That's correct, yes. Long in the tooth. Started when I was early 20s and have been a surveyor ever since, working again primarily in the AEC industry. So it's the built environment, land and measured building surveys, measuring everything from grassfield sites for new builds and existing asset conditions from small houses and residential, right up to large hotels and sort of hospital suites and that sort of thing. So,
right, a wide range of services you provide. So looking at your website, if I know that correctly, so you do drone scanning, 3D laser scanning, measured building surveys, topographic surveys, and CAD services, right? So just curious, what are the CAD services? So you mentioned a couple. So just besides the equipment and the scanning, what are the CAD services that you provide?
Well, we provide, in general, it's everything from a 2D solution. So the typical things that architects and project managers, designers will need, such as floor plans, elevations or facade surveys, and building sections. We produce those as flat 2D CAD plans. And then we do 3D modeling. So there's 3D models of the AutoCAD or this ARES Commander CAD desktop solid modeling, parametric modeling with other software suites such as Revit and the like. So encompassing everything really from the 2D flat things right through to 3D models.
Great. So are there any, or in other words, what are the kind of important points when it comes to your CAD services that your client's looking for? So when it comes to the deliverables of the CAD package you provide for the clients, what are the clients concerned mostly about your delivery of the project?
Well, it's like all information drawn. It's the accuracy that needs to stand behind it. So, Precision Survey Solutions are a RICS regulated firm. I'm a member of the Royal Institute of Chartered Surveyors, as well as a member of the Chartered Institute of Civil Engineering Surveyors. And any CAD drawing can look great. It's the back engine that we do. So everything we measure is with up-to-date modern technology. So laser scanners, handheld SLAM-based scanners, modern high-end drones. So not just the off-the-shelf ones that people will use for YouTube videoing. We use high-end photography cameras hanging on professional enterprise drones, and it's that information that is then collated at Survey Network Solutions. So we put in survey grids, and that's what we ensure our clients and customers that the deliverables we're producing is all founded around solid survey technique, rather than just measurements with potentially hand taped and the like. Our field exercise of choice is these new technologies. So laser scanning, it gives us the better accuracy information because we're measuring millions of points rather than just a few points around a room. We're actually collecting the asset in its entirety with millions of points to show verticality, how the walls may deform. We're capturing information that may or may not be requested by the client at the early stage. They may come back to us and say, "Oh, we now need a section through, a different part of the building than we thought," or a reflected ceiling plan, for example, because we use these technologies such as laser scanners. It gives us all of that information that we can then work up through these CAD platforms to deliver up exactly what it.
So you capture pretty much everything you feel you require based on the scope of work, and then based on the client requirements, you might deliver them certain sections of the scanned asset. It makes sense. So from a client point of view, as long as it's accurate and as long as you have arrangements on what you are being asked for in terms of delivery, accuracy is one of the key points, obviously, in this industry. But now, from your standpoint, being the main person in your company doing all of this work, what are you looking for in terms of the software, in terms of the equipment, which we can cover it next time. But mainly the software. What are your prerequisites for the software itself?
Okay, well, we'll stick with the discussion for today, which is the CAD platform rather than the 3D modeling side of the parametrics of Revits and things like that. We need a CAD platform that's got all of the tools that we need to allow us to navigate our way through that deliverable that the client's asking in a very simple manner. It needs to be robust. It needs to be cost effective for us. It needs to be a solution that we at a price point that we can work with. And because all of the measurement data that we're collecting is large data, it's mainly point clouds, whether it comes from drones, handheld SLAM technology, or terrestrial laser scanners. We need something that will allow us to handle that large data set within our CAD environment so that we can move the on-field or in-field measurements captured by those devices through to the final deliverable for our clients. So it needs to be ease of use. It needs to be adaptable. We need to be able to put, third-party extras in there. So whether that's Lisp routines, for example, or plugins, those sorts of things. So it needs to handle all of that, and it needs to handle these large data sets in a very easy manner. So it needs to be swift in terms of its processing capabilities.
Yeah, totally makes sense. So like you said, talking about 2D drawings and 2D CAD deliverables, you have been a long standing user of AutoCAD, I believe, in the past. So myself as well. And we know that AutoCAD has been an industry standard for 2D drafting in many different industries. But what are the perhaps superior alternatives to AutoCAD or generally 2D CAD softwares, especially when we're talking about point cloud file handling, processing speed, and maybe other benefits in 2025? So now AutoCAD has its run, but perhaps we have something new or better in the industry.
Yeah, as you say, I predominantly grew up with AutoCAD from Autodesk, so we learned our CAD skills around that product. Even before the Windows sort of base systems, it was in the DOS days. So, yeah, it's great. The trouble with Autodesk, as you say, it's the industry standard that people go to. Its price point is one of the things. It's a licensing subscription. An annual subscription is around about £2,000 there and thereabouts. And it handles point clouds through its RCP and RCS format files that it indexes. But I always find that it's a little bit cumbersome when it comes to navigating your way through the point clouds, and that's one of the things that we need. So we, a number of years ago, looked at other solutions out there, and there are a number of alternatives to AutoCAD. And one of the ones that we found was ARES Commander, which for me was the choice. The reason we made that choice to jump across to ARES Commander was the out-of-box solution from being an AutoCAD user. So from the moment you start ARES Commander, you instantly feel at home. You know exactly what you're looking at. It feels and resembles the same as the Autodesk product. Navigating some of your additional add-ins or plugins such as Lisp routines migrate across straight away. So your setup, your tool palettes, your ease of use and navigation is all very familiar. So if you know how to use AutoCAD within a matter of minutes, you are up and running in ARES Commander. And that was one of the things for us, because when training our new guys, what we didn't want to have was people stuck on historic Autodesk mentality in terms of the command structures they knew, the ribbon layouts, etc., etc. We wanted to be able to make sure that any incoming new CAD staff would be able to function with the older it was done on Autodesk. So for us, it was straight in that, it's an out-of-box solution. It looked immediately familiar and made sense for us that would be the product we did. And of course, the price point is, half. And there are more licensing options with ARES Commander than just the 1 year subscription and rolling through that licensing option. There are some perpetual options for ARES Commander if you want to go through that route. But again, it made sense to us that it was a little bit more open in terms of its licensing and how it was going down that route. And of course, the Undet plugin. I've used Undet when we were AutoCAD users. When we first were looking for, so historically, I used to use a different plugin via Autodesk, which then moved and migrated to MicroStation, and was sort of taken down that route. And we were looking for an additional point cloud solution other than the native Autodesk version, and found Undet. And Undet obviously has a solution for Revit, has a solution for Autodesk, AutoCAD, sorry, but also has this solution for ARES Commander. So for me, it was a familiar plugin, and we can move through the plugin in a short while. But for me, that familiarity of having a lower price point for the CAD, which did everything that we needed it to do in a fast and efficient manner, along with the point cloud engine plugin that would allow us to work with our large data sets again in an easy and swift manner.
Right. Sounds like a win-win situation here. So you pretty much laid out all the key reasons I would imagine anyone working in AutoCAD or other 2D CAD software would be looking the other direction, perhaps looking into discovering ARES Commander. So you laid out the reasons, and today we are going to talk about ARES Commander and Undet within this software, and the reasons you mentioned why it's beneficial to Precision Air Surveys and yourself. These are the very reasons why Undet, as a point cloud software developer, has chosen ARES Commander, a 2D drafting software, as its companion to be packaged in a suite, which anyone interested can look up on our webpage. So we do offer ARES Commander plus Undet add-on for ARES to work with point clouds and do all the things that companies like yours, Simon, does pretty much every day. So it's a really good case study for us, and you definitely have plenty of experience already within ARES. So I was going to ask you, how do you find ARES and Undet offering? You kind of explained that already, and we can go into a bit more details once we open up ARES. I was going to ask you, how does Undet alleviate point cloud processing and delivering end results to a client? You kind of touched on that. It alleviates in a major way when it comes to processing the point cloud. If the engine is faster, that just means, I guess, saving time every time you work with your point cloud within 2D CAD software. So that's something we also tend to tell our customers who are interested in 2D software, and we always try to highlight the speed and efficiency of the graphics engine that ARES Commander has, and then Undet can use that as well. So we can go into your screen perhaps and have a look at some of the just overview of ARES, how it looks like, and perhaps some of the functionality, some key functionality, user interface, ease of use, and then basically how Undet looks like in ARES as well.
Yeah, of course. The ribbon structure that you would be used to seeing within Autodesk environment, and anybody who's used that Autodesk environment would be familiar with looking at this in terms of the tabs at the top, as I said, the working environments and the ribbon structure that you could move through, and again, tools or commands that if you're a command line enter, if you wanted polyline, for example, the commands that you're used to using with AutoCAD are the same commands that you're used to using within ARES Commander. It has the same sort of properties boxes, so you can have design resources, you can have your properties boxes on the side, all of those types of things, opening and closing drawings, saving, exporting and printing, all very familiar. So as I said, those people that have used Autodesk before and in the AutoCAD environment would open this and pretty much will be up and running straight away. They could open a current drawing that they were working on within this environment and continue to work. There are a few differences, very, very, very minor in some of the commands, but of 90%, 95%, let's say, of the usual commands, if you're using the command line, are the same. They're also available up on the ribbon, so any new people who've been doing CAD since the ribbon structures were out a number of years ago should be able to find exactly the tools that they want. And again, right-clicking and customizing your ribbon and your toolbars is pretty much the same as you would find in Autodesk itself. So that was one of the things that we, immediately knew that this was going to be the solution for us because of the ease of navigation. We could take all of our trained CAD staff that have worked on AutoCAD before, migrate immediately into ARES Commander environment, and pretty much be up and running straight away without any downtime lost. So, and that's the benefit of what we had. We had some original third-party Lisp routines that we'd generated. They work instantly. There was only a couple of Lisp routines I think we had where one of the commands was slightly different, so it fell over at that command point. But the moment we edited the sort of Lisp routine at that point, all was working again. So for us, it was a win-win. It was straight up and running, no downtime, and people were very familiar with what they were doing and could carry on working pretty much straight away.
Yeah, it does in fact look very familiar to any AutoCAD user. It just has this orange color palette going on, which is just quite an interesting point of user interface kind of feature, I guess. But everything else really seems very familiar. I imagine the logic behind drawing, typing commands is pretty much identical.
Yeah.
Great. So Simon, what are the first steps? And actually, before that, how does Undet plugin fit in the ARES user interface?
So when you install the plugin, obviously you get the suite of ARES Commander with the plugin. The plugin comes in and it sits primarily on the ribbon bar, on the menu bar up here. And if we choose I've got to go to the Undet menu. It has its ribbon, and predominantly all of these tools in the ribbon are the tools that will allow you to manage your point cloud project. So you can either open a project that you've indexed already. So just like AutoCAD or Autodesk products, Autodesk uses the RCP and RCS solution. So any third-party or native file formats such as the laser scan FLS files from Faro or the Leica format files, E57s or LAS, any of those types of large point cloud data gets indexed in terms of Autodesk. They'll index that either through the indexing within the AutoCAD, or they'll run it through recap to end up with their point cloud project. The RCP project and RCS files. Undet will do the same. It will index these incoming file formats into a data structure that it uses within its plugin and allows us to navigate our way through that data. So the first part is the project management. We can open an already indexed point cloud. We can, of course, create a new point cloud from new data sources and continue to work whilst that's running in the background. We can close them. The transform, we all know about that large coordinates and large point cloud data. It tends to give graphical issues and slows things down massively. So there are a number of ways around that. One is you can transform that at data source. So remove some of the larger numbers just and work locally within that and transform your 2D digitized data later. Or you can use the transform function within Undet to bring that nearer to the origin for the working environment, such that once you've finished, it will then allow you to transform that back to the full Ordnance Survey coordinates in terms of the UK or other geo-referenced coordinates in other parts of the world. So that's the first sort of area. The scan data area allows us to, one thing to mention is the point cloud engine runs in the 3D wireframe environment. So if you're not in that environment, Undet will, of course, give you a solution on the screen to say you need to be in that environment. And we can, of course, navigate to that quite quickly. But when we've opened a project, the scan data will show us what data is within our point cloud. We'll bring one in a second. We have the clipping tools, and that was another reason why we liked the Undet solution. It was very simple in its manner of clipping and sectioning up that point cloud. We found the Autodesk version a little bit cumbersome in terms of how you work with their clipping and sectioning tools, whereas Undet and the plugin within inside of ARES Commander, very easy. You either clip by a line or you clip by a rectangle, and that solution is very easy and understandable and simple to manage that clipping box. We can have a look at one of those live in a minute. And of course, once you have your section box cut, you can clip some of that data either inside a box or outside a box. We have the coloring options. So if you captured RGB data within in the on-site operation, you can view that in the RGB colors, or you can interrogate that in its intensity. A grayscale, you can look at it by height or by a plane. You can set Undet to look at a plane and then show you colors moving backwards and forwards from that plane. So you have a lot of coloring options. And as we know that when you're trying to digitize from a point cloud, not all one intensity shows things, so you need to manage that intensity ramp slightly just to bring out other details in and out of the data that's collected. You know, a white background wall with a white feature on it, it tends to look like it's the same intensity. And there are some tools in here to allow you to manage that visual aspect of what you're looking at. So that was a neat option. There are some setting tools to allow how the graphics of your machine, how the you know the RAM of your machine, the speed of your machine. You know, if you've got the high end processing power and the high end graphics cards, then you can push more visuality out of the point clouds. But if you have a lower spec machine, for example, there are tools here to allow you to manage that data in a much more efficient manner to the best that your PC has intended.
So you can set up just how many points do you want to see in a particular view in a particular case, so you don't accidentally or on purpose overload your workstation, and any work you do just becomes really bogged down, I guess. So these are the good, some of the really good features that Undet has, and from what I hear, you're kind of familiar with them very much and use them, I imagine, daily. So that's great. Yeah.
Yeah. And the other good thing is obviously not just only the Undet tools, but what they've done is they've tried to put in some of the major tools that you're likely to be doing when you're drafting the bits and pieces. So rather than have to come to a tab to just cut the point cloud, then go to another tab to do your drawing or a ribbon place to do the drawing, they've tried to create, you know, the drawing tools, the modifying tools, and the UCS type of tools with layering on this ribbon. So you sort of go to the Undet ribbon, and most of what you're going to do for that day is going to be housed in one location. So it saves you the jumping around all over the place. You are a ribbon user, then you know you're going to find that most of your day's work is dealt with by the Undet ribbon. Without the need to have to come to a ribbon to cut your section boxes, then go back to your home ribbon for drawing, and then come back for an insert ribbon. You know, it's all neat and tidy and housed in one sort of area. So that was another good thing for what you know we found that we needed for our workflows. You then have some feature extraction and some inserting tools. So we have the tools of 3-point walls, for example, creating auto lines from the point cloud. So you can get the software suite to help to do some of that automation if you want to. We also have some tools to input some of the features. So doors and door openings, windows and window openings, recesses and those types of things that generally you're doing all the time. And rather than inserting a block, positioning the block, rotating a block, scaling a block, all takes time. And these sort of tools that are in the suite speed up that processing immeasurably. You know, in terms of people who are having to do that, inserting a block by an insertion point, rotating it, scaling it, getting it ready. There's 3 or 4 commands there that you've got to do for everything. Whereas with just a few clicks, we can use the Undet suite to help move things forward in a much faster and quicker solution. They have a workspace in terms of its area. So when we've sort of got to a point where we want to do all those blocks and bits and pieces, we have a lot more information in terms of how we want to put in. So we talk about a section view where we're putting doors and windows in. We have a floor view where we can start to put furniture aspects in terms of sinks and toilets and sanitary ware, floor markers, those types of things. Ceiling views, again, we can put annotations on the ceilings from this ribbon-based approach, all of which are seamless and fast, and in the approach that Undet have taken in allowing the user to put that information in. And that's one of the things that we really like. So that was a benefit for us in terms of that. So you also have a template drawing that comes with your suite, which holds a series of blocks and textural elements that can be used with these tools. So that makes it nice and easy that you have a door block in there and window blocks, which are dynamic blocks as well. So in a minute we can have a look at how they work. Because putting one symbol in and then allowing you to choose that into a single door or a double door, flip the door to the other side for its opening or the other side of the wall, are all tools that means that you can minimize the amount of blocks you have to work with and the training solutions on that side of things as well. And there's one thing that we sort of haven't spoken about so far, which is that with the suite, you offer a browser solution.
Correct.
And I think I may have a browser that we can look at. What it is, it's in effect the way I try to describe it to our juniors. It's a portal. It's a portal between the digitization that you're doing within your CAD environment. So you're in your CAD environment looking at point cloud. We all know how difficult that is when you're looking at a whole series of dots on the screen. You don't know whether you're looking at a column or a filing cabinet without photographs or some other visual aid. You're not actually 100% sure what you're digitizing. And one of the things that we hear from a number of clients, that because we also provide the point cloud to clients, they'll say, give us the drawings, but can we have the point cloud that we'd like to work with? They always come back and say, how do you work with it? We don't know what we're looking at. And it doesn't matter how many photographs you give them, they can't seem to get that visual grasp of what it is. And it is very difficult. If you're trying to digitize something, you don't want to draw a line around a cupboard in a kitchen thinking that it may be a column or some sort of recess or rebate or whatever. So we use the web share browser, which in effect puts you at each of the scan locations. So looking at the scan location from here, we can see that the number of the scan that we named in the field. We have a live coordinate that we're running around with, adjacent scans that we can navigate to via a single click motion, or we can pull up a map of where all those scans are and choose an individual scan if we wanted to, and jump around those things. But it's not only a visual aid, because there is a dynamic link between the browser and the digitizing solution. So if we have in here a point cloud that we want to navigate to a certain, so let's say, for example, we've cut a plan slice at 1.5 meters above the floor level, and we're happily drawing wall information, and we want to go to where the beams is. You either need to know what the level of the beam is so that you can move the point clouds section up to that point where the beam cuts through the point cloud, or using the Undet Browser. If we sort of went into an internal, I don't know whether we've got any beams in this internal, but if we went into an internal space, for example, we wanted to see the point cloud at the ceiling level, we can use the tools in the browser to navigate by just simply clicking in the browser, which will then navigate the section that we've cut to exactly the level that we want it to go. So we've got a plan section sliced, and let's say it's 100 millimeters of data that we've sliced, and we've had that cut through the wall line down here. But we then want to go up and digitize something on the ceiling level. All we need to do is, using the tools up here, the navigate, the translate view section, we would turn that on, click the ceiling, and the whole of that point cloud section would move to the location here, centered around that point that you've picked. So for us, that tool to navigate the point cloud, and it works in elevation mode as well. So if you're drafting an elevation or a section, you can move that point cloud backwards and forwards by clicking various faces within that browser to navigate in and out. So if we were to, let's just try and get two windows going here. I presume you can see both those solutions, can you, at the moment?
Yeah.
So what we need to do is, if we come to our Undet tab, I'm going to open the point cloud that we have just opened in there. So we're opening up this index point cloud. We can talk about the indexing in a minute, to show you how that indexing goes. But I'll close this down just so we've got a bit more space.
So the browser sounds like a really useful piece of software that's packaged up in the ARES and Undet solution. And especially a direct link, what you're now showing, it seems like really something that could save you time navigating the point cloud, especially if you have a large point cloud and build a set.
Yeah, absolutely. So if we were to look at the thing in here, we've got a point cloud that we've pulled in at the moment. It's being displayed in an RGB, but we don't have RGB in everywhere. But if we change this to an intensity setting, you can see at the moment we've got an intensity map that we've got here. Those settings can be changed. We go to the intensity map if you prefer to look at your intensities in varying colors, so you want to see more of a rainbow effect, we can transform that into that. So some of the terrestrial laser scanners output their intensities in different manners. Some people are seeing it red to green, the shades of blue or whatever it might be, or grayscale. So we have the functionality here to change that sort of aspect of how the point cloud looks. So we can change transparency of it. So if we're drawing elevational views, we can make that point cloud a little bit more transparent to see the line work that we're drawing, just to make sure that we're going in the right manner. This, of course, is the full point cloud. We have everything here that is captured by our project, even though it's fairly small in the middle. And you can see that it's fully 3D. We're not looking at just a flat image or something along those lines. It's a full 3D point cloud that's that we've captured and are using. I'm typing it right. So the first thing that we would do before we get back to the browser, we would cut a section. We need to cut something. We're not interested in digitizing around here. We want to start moving the data into something that we want to use. And here's our building in here. So in this instance, because we would potentially be looking at drawing a floor plan, we would use the clip by rectangle. So clipping by rectangle, we would just take the clip by rectangle tool, and let's say we clip a rectangle around the box here. It would then go through and take away all of the points that are not required, and only leave us with the points that are within inside this this box here. And we want to have a look at this. This is the clipping box, and again, if we look in a 3D environment, you'll see the clipping box again has grips. We can utilize the grips if we want to, just to make the box bigger, smaller, or drag the box to a thinner slice. Or you can use the properties of that box to say, in terms here, the height of that box, let's say, is 0.1 of a meter, so 100 millimeter slice. We've now got a 100 millimeter slice, as you can see, of data. But at the moment, it centered itself around where it was before, and we've now not got much information going on. So the beauty of what we were talking about in terms of the let me find myself in a different room. So let's say we're in this corridor here, for example. If we want to take this section to cut through, let's say halfway through where this window area is, we use the tool which is translate view section.
Yeah.
We're inside of our thing, and if we translate the view section by clicking in the box, what will happen is the view section automatically navigates ourselves down to position the center of our sliced section at the point where we've taken our information. Again, if we want to go up and look at some information up on the ceiling, we could click and it translate this view section up to that location there. So it's a really, really neat tool in understanding where your data is in terms of what you're going to be drawing. And that's, as we said, that's one of those things that when you're looking down at just a data set that's that is just a load of dots and lines, you don't know what things are. And without that visual context, you haven't got any idea what it is that you're digitizing, and you could incorrectly digitize something or miss something that should be digitized. So it could be, you might presume that to be a column or something and draw it, or it might be that you've missed a column because you thought it was a cupboard.
Wow.
So the ability to navigate your data is immeasurable for us. It's something that we couldn't really do without. If we wanted to look at a radiator, for example, where is the radiator in the point cloud? Well, we click on the radiator and it will navigate our point cloud such that we'd be able to find wherever that radiator was. Probably is where the window was, wasn't it? Trying to find where he is. But you get the gist of that.
Yep.
Use that. So So allowing users to have a visual record of what was measured, because let's remember, it's not always that the person drafting was the person who measured the site. So
Exactly.
maybe the CAD drafter with the prerequisite skills of a drafter, and that alleviates the point of saying that the people who are the surveyors, the people who are good at understanding the site operation, putting survey control and measuring the building correctly, aren't always tied to just having to do a on-site measurement opportunity or exercise and then the drafting exercise. You can manage your staff and the training and the abilities they have in the areas that they have by allowing these the CAD draftsmen to actually put themselves inside the building and navigate their way around the building in a very simple manner, such that they could then say, right, I need to draw this room, and they navigate their way in by translating that view section. The view section changes, and they can clearly see what it is that they're trying to draft, whether it's the windows of the thing, the doors, and how the walls are approaching.
Yeah.
Um,
Uh, Simon, that's a very good point you raised, actually. So one should understand that a person who is drafting and the person who has done the scanning are not the same person. So someone that's drafting has not been to that building project or structure and has not seen it from the outside or the inside, and they might just be receiving the point cloud files, then indexing and then moving on to drawing. So having something on the side, as you said, a visual aid that's quite comprehensive, something like Undet Browser, that just makes the whole process for someone who's drawing a lot more efficient and just easier to understand what exactly they are drawing. So I imagine in your daily business, you would perhaps have two monitors, right? One of them might be running Undet Browser, the other one might have ARES Commander where you draw, and like you showed, the synchronization and the link between the ARES and the browser is really effective in your daily work as a person who's drawing, for example. So
yes.
so that's amazing. Yeah.
Yeah, that's absolutely correct. I mean, as you say, we work with multiple monitors, and it does give that ability. Sometimes the surveyor does do the drawing, but it gives that perfect opportunity for someone who's never been to site to actually look around, in that sort of 3D. Everybody's used to using Google Street and those things now, so
Yeah.
it's the same aspect. You can zoom in and say, okay, I know I'm looking at a window. I know I've got some radiators to worry about, or some sockets if you're dealing with that aspect of the property, and you get a feel for what it is you're drawing. You know that that you can see what's happening with the walls. If you just want to see the walls without cutting through the windows, well, you cut them up above the windows and doors, such that you're only seeing the work, the physical shapes of the building. So it makes much more sense to have that opportunity to manipulate that data set in a
Yeah.
very easy and efficient manner.
Yeah, it almost feels like a game environment, although except it is an actual building or asset that has been scanned. So that's really good functionality to have. And as far as I'm aware, you can upload your point cloud file to a server and access the browser on the web, and you can share the link with anyone you like within your company or outside your company who had the permission. So, and not just that, Undet Browser comes as a separate installation file and just becomes a desktop icon. You can also translate most of the functionalities or some of it, some key functionalities to a web browser and preview your point cloud that way. So
Yeah, no, absolutely. And um, it's also the fact of one file that you write for your CAD package, the Undet indexed file is a file that you use to open in the browser. But it's also you have the opportunity, if you are Faro users, to have the Sphere XG account, so you can use the Sphere XG account as the browser file. If you're not a Sphere XG user, then you can write at the time of indexing the the Undet browser file. So if we looked at the indexing side whilst we're talking about that, the indexer again is like a little standalone indexing suite. You can index your data depending on the type of projects that you're working with. So the reason you have sort of four areas, all of the data that you've captured and that is going into the input file, so whether that's FLS or E57 or a LAS file, all of the data that's contained within those files is going to come into the Undet engine.
Mhm.
These solutions here are just because obviously if you're using large hectares and hectares of data with a drone technology, for example, you want to make the data that you first initially see before you cut any sections, you need to sort of minimize that a little bit. So basically these are doing that. They're taking, a point every meter or so, then they start working themselves down to, a half a meter, 100 mil, let's say, and down to 30 mil. So when you're working with small projects,
Mhm.
and monuments and buildings, you've not got as many points in your data set as you would do if you'd flown 50 hectares with a drone and got, billions and billions and billions of points. So the indexer gives you the opportunity to package that data up in its first view in a much more manageable chunk, so that when you start your computer, there's no smoke coming out the back, etc. So you would select one of these solutions depending on the type of thing you're doing.
Yeah.
We're doing a building. You will import the type of file you've got, so whether it's an FLS file, whether or not you're looking to bring in where would that be? Let's have a look. Storage E57 data. So
Mhm.
you can mix and match. So you can bring in E57 data and FLS data and LAS data, because quite a lot of the drone technology sends out LAS files, laser scanners. You might have E57 exported or native solutions such as FLS. You can populate all of those in and write that thing in terms of its indexing. But if we just take a couple of files in here, they would come in, tell you the format that you've done, but we can at this stage, if we wanted to, select a number. So let's say, for example, these scans here related to the outside of the building.
Mhm.
We could select these files and we can add them into a group that we could call external. Oh, and then we could group these, for example, into internal. And we would then index our project. What that would mean that when we were in terms of our projects and we see the scan data, we
Mhm.
can look at the scan. So in the scan data, we see which clipping boxes we've got active. We can have more than one clipping box. You can have clipping boxes that are very small to navigate your way around a room. You can have a clipping box that can be deemed the building size, so you can look at the building as an overall, or project size. So you could have a section box that's very large. You can duplicate these boxes. So if you've got a box created with 100 mil slice, you can duplicate it, manipulate the grips, and have that sitting there waiting. Or, of course, you can have solutions that are at a certain height and position that you want to be at. And so first floor slice, second floor slice, something like that.
Mhm.
But in the scan data, at the moment, I've indexed everything and it's just a whole load of data that I can turn on or off. But with groups, it means that if you would section some of these bits and pieces into a group, and let's say they were internal, I don't know, whatever, again, it means that we can turn on the whole group of data rather than individual bits and pieces. So if we said, let's turn off that group of data, then you'll see some of that disappear. So if we just turn off all of those first, that'd be probably the easiest thing.
It gives you greater control of the
Yeah, much greater
yeah.
controls, but we've got no information that we're displaying. Rather than try and shift and right click the bits that I want to do, I can have this saying, well, these are all of my internal scans, and I'll turn on all of the internal scans in one go. So the ease of use on seeing which data, the way we use it is we'll perhaps group things into ground floor,
Mhm.
first floor, second floor,
Mhm.
external, for example. So if we're digitizing just the ground floor, we will have just the ground floor turned on. And that means that you're not going to get mistakes fed in from other data sets that you may not want to include, or find yourself in the wrong vein. If they're turned off, you won't be seeing them, and there's less chance of you digitizing something in the wrong place, for example. So all of that is available at the indexing stage.
Right.
Or, of course, once you bring data in, you can you can regroup with inside
Mhm.
of the data set here. So there is also logical classes, so you can classify things to say, you might, for example, find some erroneous data that you don't want to include. So you can classify that data into an erroneous category and turn that data off by windowing around and doing that. So the functionality that we have in here is fantastic. It allows us to turn individual scans on and off, or groups of scans on and off, and allows us to navigate our way through in a simple and easy manner. You can, of course, turn on the bubble views. And these are the bubble views that come with your E57, your FLS data, to allow you to see that 360 data in your browser and stuff like that. So in terms of functionality, the indexer can then run away on its own. So if you are digitizing and you then have another pool of data that you want to digitize ready, you can have this indexing in the background whilst you still can work onwards. So
Right.
that's just a brief insight into what the into what the indexer does. Once that's indexed, then of course you open it via the Undet plugin to digitize what you're after to do.
Right. And indexing is the first point of first stop in the entire process, right? So
Absolutely.
you have the scanned files, you want to index them to be able to use them and then digitize them. And what would be the next step in your workflow after you've done the indexing?
Yep. So in terms of indexing, once we have our file, we would import that file in via the open into our ARES commander. We'll have our template drawings or whatever it is that we're doing. The first thing for us that we would do is we set ourselves in alignment to the building. So we set up a UCS which is a user coordinate system, to set ourselves square to the building. Every building will be measured. There are slight nuances and inaccuracies and deformation through a building. Generally, we don't want to be drawing those. We're looking for a standardized alignment of the building. We're not trying to draw every 5 or 6 millimeters that deforms, unless that, of course, is a heritage project and it's been asked for that. They might want to see that if that's the case. But typically, what we would be looking to do is we'd be looking to find the common alignment for the building.
Mm-hmm.
So, we might choose the UCS of a wall. So here we go. We'll just say we're aligning ourselves to this wall. And we would then start to look to see whether it's sort of like a single alignment, to the building. So yeah, that looks reasonably good. That looks reasonably good. And once we've decided upon our standardized UCS, we might save that. So under our named UCSs here, we have an unnamed one. We'll rename that to say, I don't know, plan, for example, which would then be in our user coordinate systems that are up here so in the Undet ribbon, we've got access to our normal world UCSs, but also any of the saved and named UCSs that we've got. So we now have a plan UCS that we could then use to start digitizing and drawing walls. So we would, come into our layers that we want to do. Is sort of slightly off the screen here, but we might decide to use a layer for internal walls, for example, in this instance. And then it's for us as CAD operatives to start navigating our way around. If we want to use the drafting tools for ourselves, we would go along and start trying to formulate what we think the drafting of the building is, and close off ourselves a shape. Have a look at what it is. You can see that it's not quite square to what we had before, but in fundamental terms, it is. It's what we've chosen as being the solution. We might draw a rectangle if we think it's absolutely perfectly square, for example. So we'll draw a rectangle in there. We see it's not quite square in this corner, but you might decide that you're changing something on this bit. Whatever the tools and methodologies you're using, you would then start to work up your floor plan shape. And use the tools and experiences that you have. And again, I'm going quite fast around this, just so you get the concept of what that will be. You might decide that you want to keep that one slightly off square from the other solution, and the same here. That might be a deformed wall that you want to keep in, and finish off your drafting, whatever. And you end up with digitizing the walls. The program has a hide and show, so you can turn on and off the point cloud very quickly and easily at any one time as a global on and off. So rather than have to worry about individual scans coming on and off, we just want to globally hide and show. Are we happy with what we're drawing, making our way round through the building, etc.
Mhm.
Fundamentally is how we would go about doing a plan. Once we've drawn our room shapes, we then start to populate that with the doors and window type symbols. So if we try and put ourselves um, in the building somewhere, put ourselves further up. Let's go for, and again, inside the browser, you can, these are all the scans that we'd named. You can see them in here. They're all held within this, in the browser. So you know, what scans we're sort of looking at. So if you wanted to go for scan 72, because that's what we're looking at, this data is including at the moment, this data we're looking at is only the data that's ticked on. So I can see that 72, scan 72 is within this data set. So I find scan 72 if I wanted to in that instance. And we can then navigate ourselves to seeing perhaps where the window positions might be and the door positions. So let's say, for example, we draw another polyline in here somewhere just to get things going. So, for example, we have a door in here. So we clearly see it's a door. And one of the options that we might be doing is we now decide that we want to put some doors in. So in terms of our, I'm going to switch over to an undet ribbon, just to make it easier to get the tools. In our section view, we have the ability to put a door in. Now we have two options. We can just put a symbol of a door in, nothing else, or we can put a door with an opening. So one of the things is that people might have to put a door in, rotate that door around to its position. Then they have to strike some lines between the reveals of the door and cut and trim that out. But if we were to look at a door with an opening, it will ask us to select our first cut point. So let's say we go in and we pick a point here, another point on the reveal here. You can see it's already drawn the cut marks, and let's just place a door. So here's a door that we've placed, but the door's in the wrong side of the bits and pieces. It's the wrong shape around. So what we can do is we can flip doors and bits and pieces around. If we wanted to move that across to here, we can do. And therefore, we've got the ability to very simply put a door in with door cuts. If we want to decide it's a different type of door, we wanted it to be closed, it's a dynamic block. So we can choose from the drop-down list a closed blocks, or it may actually be a double door. We put a double door in, or it could be a sliding door. So we've got the options of putting a different style door in just by placing a few clicks on the screen. And you can see how simple that is to place a door. So if we say it's a closed door, it's very simple to put a door in. It's been trimmed already. It's at the right size, and we've managed to position that in the correct place. If I had to do that manually by insert, find the block I wanted to insert, place the insertion point here, then rotate it, then scale it to the right size, and then trim the doors out. There's a number of commands that I have to do, which takes a little bit more time than perhaps the tools that we have for things like that.
It's pretty amazing automation, actually. So it looks like Undet has paid enough attention to some of the automation tools that you presented previously, and in particular this one for doors. I would imagine the same idea goes for windows, perhaps, and automatically adding annotation with a couple of clicks only.
Yeah, well, let's just presume, you know, we'll just put something here just to fire that there's a wall there. Let's say this is a window, and we wanted to put a window in here. Again, we can choose window with opening, so we could choose a window with an opening, just cut a couple of points, and then we can place a window. Let's say we place a window there. It's a dynamic block, so again, we can pull bits and pieces out from the block. We can decide if we haven't got it quite right, we can stretch and pull that block. We can move that block, you know, and those sorts of things. So very simple in terms of the tools, and it's all been cut through for us, and we don't have to do all of those extra bits and pieces that we need to do.
Yeah. So I imagine in a larger footprint of a building, if you arrive at the point when you have a floor plan drawn up and you're only fixing doors and windows, but you have so many of them that you realize it could take several days. With these little features and tools, inserting doors and windows just becomes quite a lot much faster, right?
Yeah, absolutely. Yeah, it does, and it's the it's the ability to do those things that when you're, as you say, when you've got on a project, you might have 500 doors to put in, might have 500 windows to put in. If you're only using a quick command that's a couple of clicks of your mouse and the window or the door is in, imagine how much time you save over 500 of those if you have to go insert, place the door, rotate, scale, all of those things. Unless you've written some other form of automation, which people do, then you've got all of that exercises to do, which just takes that additional time. It might not be a lot of time per door,
Yeah.
wide out over a large project. That can they evaluate and equate to hours, and hours means money. So you're moving on to another project a lot sooner than you were. So
Yeah, it kind of accumulates in your project. So it seems like Undet has every little step covered, from indexing to auto-inserting doors and windows to perhaps drawing walls in a more automated manner, and perhaps with the AutoLine tool, just creating a polylines much faster.
Yeah, exactly. And it's with the auto wall tools and things like that. What it will do is, it uses your UCS and follows the point cloud best it can. If it finds a point which it can't go any further, then it stops and it allows you to interact with that and deal with it. So all of these tools are embedded within in the plugin. Let's say, for example, there was a column that stuck off the wall. This opening and recess tool. If we just clicked that we're going. Recess tool. Make sure we pick let's go on here. Not getting it. So it doesn't seem to be picking my wall. Let's try recess. Yeah, I've cut an opening. I don't know why it's not cutting the recess. Recess. Oh, yeah. So we select the line, and we select 2 points that would denote, let's say, for where the column was and how far into the room it comes,
Mhm.
and we automatically got a column
Mhm.
where it's trimmed and done everything. If we want to recess into there, it's the same command. We'll pick the line, 1 and 2, and recess ourselves into a fireplace, for example.
Mhm.
Saves us as drafters having to, to go around and follow these things. And with the point cloud on, you'd literally be using the point cloud to determine the thickness of those recesses and columns, etc.
So normally you can control the point cloud and just the exact section that you require for a particular drawing. And in the other spectrum of your daily work, you have tools for automating your work, which the few of them you just showed now just seems like they really save time for anyone that's drawing sections or plans or elevation.
Yeah, exactly. So let's just take, for example, see, Undet also in the browser, it has a series of predefined types of scripts that come embedded for you to use if you want to. And what it is here, we had the translate view section earlier, but this is the scripting tool, and we have the settings for the script or a drop down list to add some things. So let's say we wanted to look at adding a floor to ceiling height. So in a typical drawing of a floor plan, we'd have a floor to ceiling height. So we'd choose floor to ceiling height. We turn on the script, so it goes black to say we're now in the live environment of script. Now, floor to ceiling height, remember what we would potentially do if we didn't have the browser. So let's think about what we'd have to do. We may have to cut a sectional slice, work out what the floor level is, then work out what the ceiling level is, insert the text, manipulate the text and type it in. Whereas what we can do is say, well, we know where the floor is. So we've turned on script and we're asking for floor to ceiling. So there's the floor and there's the ceiling. And what you'll see is that the browser has passed across to the CAD in the location that we selected and done the maths for us. So the beauty of that is it's not user defined. We're not having to do that maths ourselves. It's automated, which means it's less likely to be a mistake. And the usual way that we would have done prior to browsers and things like that is we would have then said, right, well, we'll now copy that to the next room. We go to the next room and we ask for what the floor level is and we change that information. That again is if somebody phones and you've copied it and you haven't changed it, you've forgotten about it and you've now got inaccuracy in your drawing. So to add automation means that with the scripting on, we can say floor and ceiling and we get a floor to ceiling height automated. Okay, if it's in there, it's been done automatically. Likewise, the same thing. We could go for, I think we've got beam heights in here. Somebody who's got to find them all. Beam head height. So we have a beam head height. By taking the head and the floor, or the floor and the head, whichever way around, and it does the maths for us to determine where we've now got a beam in our data. And if we wanted to navigate ourselves to that data set, we could click on the beam, and you'll see that the beams I've moved everything. So, but you can see beams and wall alignments is easy to jump around to. So they're the types of things we do. So again, if we look at the beam height thing now, so we go turn on the script. Yeah, there's our beam height, ready for our beam to manipulate what we need to do. And that for us is the beauty. You can write your own thing, so you can use this because if, for example, we have a 3D snap mode. So, or let's say, sorry, start the 2D snap. So 2D snap mode, because we're drawing in 2D, we're not doing a 3D wireframe model or something along those lines. If we wanted to draw something and use the browser, let's say, for example, if we issue the command that we're after, so in this instance, polyline, and we said, I want to start a line from there, you'll see that the coordinates have been passed across to the ARES commander for you to do things. So if you were trying to find something on the floor or a hatch that you couldn't quite see in your data, you could use the browser to digitize that information. So it's another handy tool of passing information across. We have some bespoke tools that we write that does the same thing, but allows us to change certain aspects of what we've got. Because when using some of these tools in the browser, we looked in the 3D, actually places that text at the values that you've got from clicking in the browser. So in effect, it's 3D, and you just need to flatten those at the end of the project. Whereas all we've done is written our own script. So we changed to 3D mode so that we can pass from the browser to CAD a 3D coordinate, and we will say, let's say we want a floor to ceiling. We then give ourselves a little more functionality by what's the scale of the drawing, because that has an effect on how big the text is. So we're going to say we're drawing at 1 to 50, and it will now say pick a point on the floor. So we'll say we'll have a point on the floor, and it will say pick a point on the ceiling. We'll pick a point on the ceiling. And what it will do is it will give us our floor level instead of just, whatever the standard that you have as out the box solution. We can then have our information, which is actually flat to the drawing. So you've got not only functionality provided by the Undet suite, but enhanced functionality by writing your own scripts that you can use with the script function to do extra tools for yourself. So the scope for adding extra enhancements and functionality is fantastic. It speaks of your operations immeasurably. So if you
certain number of scripts, like you said, do come as within the default package, and on top of that, like you just showed in your daily work, you build your own scripts and then use them within the browser in ARES.
Yeah, because obviously all that's happening is if you're passing you're either passing a 3D coordinate or a 2D coordinate. So you can choose whichever one of those is coming across to AutoCAD, and when you issue your commands, you can then pass that data across and use this as a visual guide just by clicking in the screen. It's a much better way of utilizing the browser and the functionality that you already have. So that's how we would sort of start working up a floor plan. By using the data that we've collected, navigating our way around using the translate view section to position the point cloud in the area that we want to digitize, whether it's the cut through a window, finding a radiator, finding beams on ceilings, that type of thing. And then we will use the automated tools, either in out the box solutions or any solutions that we've written, to start annotating and textualizing our drawings in an automated manner, so that we're cutting out the opportunity for those errors to creep in, which is human error, basically, by forgetting to change the value of something, or as we all know, that the phone call comes in and you've forgotten where you were and you're halfway through a step and you've missed the solution. So that's how we would go about that exercise. We can sort of talk about elevational work and sectional work. So just deleted the stuff that we've just drawn. So if we come back to just in here a second, I'm just going to delete everything that we've got. I'm going to deactivate that clipping box. So at the moment we have a clipping box that's deactivated, and I'm going to deactivate that. What that will do is take us back to all of the data that we had. Remember, we've actually turned off a whole series of data here. So, if we wanted to turn all that back on, I can just shift, same sort of windows, shift and select all, find one that's off to make sure we turn everything back on. And here we go. So I may have already decided that the UCS that we have, that plan UCS, is good enough for our elevation. And I can do one of two things. I can either use the clipping box that we had. So let's just say, for example, we go back to that, and I'm going to clip by a line this time. So if we were to clip by a line and we want to go down somewhere near the front of the building. So let's just double that. And I'm going to make that our clip. What it will do is it will clip us in effect, a vertical section. Oh, turn that off, haven't I? You can reactivate any section just by double clicking them. So there's our vertical slice of section.
Right.
Again, it can be gripped and manipulated with the grips, because it's just a function box. So we can make it big or small or whatever it might be. Again, you can use the properties box to make that thin. You can get ready to, you can set up your section slider no value at the beginning. At the moment, when I cut my section, it was 1 meter thick or whatever. So we can change the way that this appears, and change the grips for manipulating different bits and pieces. And then what we'll do is we will use the browser and a UCS to so I'm making a thin slice that's vertical. And what we're going to do is manipulate our UCS such that we're looking directly at the building. So you can see at the moment, we're in effect, our plan position is looking straight down on our project, but we want to wrong way, sorry. Let's go around. You get the gist. Right. I think I've done that right, haven't I? No, just bear with me. So having a bit of a pickle because it was in the other. Right, UCS World. All that again. Right, so we're looking at our building, like we were, as though it was like a plan, but let's now go outside the building and utilizing our translate view sections. Because we, let's say, for example, want to draw the front of the bay window. Again, we can navigate our point cloud so that we only get to see, or we can navigate around the parts and part of the building that we want to do. So we're going back to that wall line, and we can digitize by using the translate view section, and we can move ourselves away in and out of these elevations without having to grab grips, pull grips, and the bits and pieces. And again, we might set that UC up, which is currently unnamed. We might name that now as elevation 1. So we can always jump back to our elevation 1, and we would then start to digitize the bits and pieces that we wanted to do for our elevations. Same with the section. If we were inside and we wanted to get inside the building, where are we? What's what we gone there?
You inside or outside now?
No, it doesn't matter which one I'm on at the moment.
Mm.
Yeah, cut. Can't see why that's not. Let's just restart the browser. Don't know why that's gone like that. Can you see any reason why that?
Could be it. Lights or exposure settings, no? Does it allow you to? No,
There we
yeah,
go.
lights are on.
Right. Yeah, that's what it was. So let's minimize that back down again. Yeah, so if we wanted to go through and we were cutting a section through the building, then of course we can just position ourselves where the section's going to cut through.
Mm-hmm.
Turn on the translate view section, of course. And then we could then digitize the section that we're trying to find in terms of that. So yeah, so all of those tools are how we use Undet and ARES Commander in a fast and seamless manner, really.
Yes, and it doesn't seem like there are any not too much glitches, but any issues when it comes to processing. So you've been navigating this point cloud for the last 30 minutes, let's say, and the whole process seems really smooth, back and forth from browser to ARES Commander. So
Yep.
that's great. Yeah. Simon, thank you. So you did a really in-depth and great presentation on the package that we offer, which is ARES Commander together with Undet add-on for ARES. And you really nailed through the process of indexing of Undet Browser, of annotation and adding annotations to your drawings, and how you would approach setting coordinates and drawing, digitizing your scanned assets. That is great. So I understand there are several reasons you're not looking for any alternatives at the moment. You have you are seem to be settled with this solution, and I imagine, like we talked at the beginning, could be the speed and efficiency of the graphics, and then just overall presence and user interface of ARES Commander that AutoCAD users may find very familiar. I imagine, as well as the costs of ARES Commander and Undet as a package, that's quite a good value for your money, I would imagine, right?
Yeah, absolutely. And it's not only that, it's the the after sales support as well. The Undet has a myriad of online training videos on their YouTube channels. They're also, or you are also, easy to get hold of. If there is an issue, the response coming back is great. So the after sales support it is better than perhaps like a worldwide industry such as Autodesk, who are trying to cope with millions of users of their products around the world. The any issues that do come up with either ARES Commander or the Undet plugin suite that goes with that are answered very quickly and efficiently. So and updates, you're always thinking and making sure that you're on top of the game and ahead of the game. As things within that scanning and point cloud industry changes, you seem to change with them at a fair rate or not. So that was another solution for us that we need, is trying to get an answer out of a multinational sometimes can be very difficult because they're not going to answer a single question. They tend to put that into a group of questions to deal with an AEC industry or a M&E industry or whatever it might be. So so in terms of finding out, we've whistle stopped through a lot of the tools and bits and pieces, but point cloud engines and plugins are quite difficult in some of the native solutions that they have. And again, straight out of the box, you'll be able to cut yourself a section and a line section or a rectangle section. You'll be able to change the colors of your point cloud very easily because the tools are simple.
Yeah.
And with the browser, it means that you can navigate your way around that super efficiently. So,
Very good. Yeah, and that's a good point to raise about technical support. From my own experience in the past, the technical support is very important sometimes, and actually crucial in some cases. So you want to have reliable software developers then that can not just stay ahead of the product development and look into the features that is going to develop for years to come, but also support the current existing clients and whatever the questions or issues they may have. And this has been one of the key ethos or philosophy at Undet. So that we kind of try to really take care of the customers, be it 2D drafting or scan to BIM. We're really trying to take care of it. So Simon, I think you've done a really amazing job at presenting ARES Commander, and not just that, you've been run through Undet as well as Undet Browser and Indexer, which is great. So I think those who are watching will take the most of it and will be able to see some of the key features and benefits and why someone might choose ARES Commander together with Undet. So you really did a good job highlighting these benefits, actually. So Simon, I want to thank you for joining the webinar. It was nice to talk to you, and I wish you luck. And I think we might see each other in the next webinar. Yeah.
Okay, perfect. Yeah.
All right, Simon. Thank you.